So even after running your code for the nth time and you're still getting that same old time limited exceeded error, maybe at the end of this video you'll understand why.
Firstly, there's this common misconception that time complexity is the amount of time that it takes for your code to execute and give the output. But that's not the case. The amount of time also depends on the number of CPU cycles, which again differs from PC to PC. What time complexity really is an expression or a notation that helps us understand the number of steps that our algorithm is going to take to give us the output. Now, there are different types of notations, but we commonly use the big O notation. And in the big O notation, the best part is that the actual value or the actual time taken for the code to run, it will always be greater than or equal to your given notation. That means for the following time complexities, O of n square, O of n square plus n, O of n square into 50, all of these will be represented using the same notation, that is O of n square, because the variables other than that of the highest orders are ignored. The reason being is because the point of actually analyzing your code and its time complexity is so that you get to understand how your code will behave when you're dealing with huge amounts of data. And in this case, if the value of n square in itself is very high, obviously small values like n or any other constant like 50, 45, etc., would be ignored. That's the entire point of time complexity analysis. The same, I have used O of n square here, but the same logic will be applied to any other time complexities like O of log n, O of n log n, and so on. We'll be discovering more about these time complexity as we go on in this video.
So as you can see, this is the code for O of n time complexity, where n I've taken it to be the size of the array. Now, the actual time complexity for this would be something like O of n plus 4, where 4 would probably be the number of CPU cycle it takes to perform the operation of, finding out the sum of each and every element. If this was multiplication, let's say it would have been O of n plus 8, and so on. But these numbers like 4, 8, or any of these constants, they are to be excluded when we're talking about very huge data sets. And that's why we take it as a common value of O of n. And as I said earlier, this was based on the size of the array. Now, if this array had, let's say, a million elements or so, and if we were to find the sum for it, at that time also we'll take it as O of n.
As far as O of n log n is considered, usually sorting algorithms implement this time complexity. In this example, I've taken quicksort, but even sorting algorithms like merge sort also implement this. As far as quicksort is considered, over here you basically take a pivot element and then partition the remaining parts of the array, and based on that you implement recursion over here so that you get your elements sorted. Quicksort is also slightly more complicated than that, and by complicated I mean you also implement a swap function over here, but the goal of this video is to introduce you to time complexities, so I won't be diving into that. As far as time complexities like O of log n is considered, usually algorithms like binary search implement these, and it usually involves the breaking down of the given data structure into smaller parts so that you can get your end result.
So now we finally move on to the time complexities. And if you look at these graphs over here, you can deduce that O of one time complexity, this one right here, is like the most optimal time complexity. But then again, it might not be achievable in a lot of cases. Apart from this, usually a time complexity of O of n or O of log n is preferred. And the thing is, O of n, there's a very good chance that most of your problems might be done under O of n time complexity. But then there's also O of log n. There's an algorithm called binary search which executes it in this time complexity. You'll encounter this over there as well. Apart from that, we've got time complexities like O of n log n, O of n square, and O of n factorial. O of n log n is commonly used in sorting algorithms, and O of n square, not exactly an ideal time complexity, but you might encounter it in some cases.